Hey you, yes you, I'm talking to you. Are you good enough at coding? If no, then meet me. My name is Suhendrasekhar Sahu. I'm also not good at coding. That's why I'm making a 30 days of coding challenge to see how my coding skills are improving. You are always welcome to join me. If you are a new user, then you can just check out my previous videos. Okay, without delaying any time, let's start our topic. Okay, so it's our day 3 and the problem I'm going to taking for this session is from leetcode. You can find the problem link right in the description box below. So the name of the problem is same tree. So as the name shows, the problem is based upon trees. So let's understand what is the problem. Given two binary trees, write a function to check if they are same or not. Two binary trees are considered the same if they are structurally identical and nodes have the same value. Okay, so let's understand the problem. So there are two binary trees are given and we have to write a function to check whether the trees are same or not, and the trees are same whenever they are structurally same. So they have given two examples like, so let's understand this example also. There is two trees are given like 1 2 3 and 1 2 3. You can clearly see that these two trees are identical, so they are same, so we have to return true here, which is a boolean type. Okay, in the next example there are the elements of the trees are 1 2. Here also the elements of trees are 1 2, so but they are not same. Why? Because they mention here that they should be structurally identical. Here it is a left skewed binary, here it is a left skewed tree, and here it is a right skewed tree. Okay, so maybe the elements of the trees are same, but if they are not structurally equal, then we cannot say that the two trees are same. So in this case we have to return false. Okay, this is all about the problem. So I suggest all of you to pause the video and think the solution. If you don't know what is tree, then go and search on YouTube. There are tons of videos on YouTube. You can easily understand it, and tree is not a difficult chapter. So if you don't know, let's move to our logic part. So how to approach the problem? Okay, first of all we'll traverse through all the nodes of the trees. Okay, this node and this node. The tree consists of three nodes. We'll traverse all the nodes of the list and we'll keep records of all the nodes which we are traversing. Okay, so then we'll do the same for both of the tree, then compare whether the elements of the list are same or not. You might thinking where the list come from. Okay, the list come from, we are storing the elements which we are traversing in the list only. Okay, then we'll compare both the list whether they are same or not. Okay, like if I'm at this node and the value is 1, so I'll store in the list 1, then I'll go to this node and find the value is 2, then I'll store 2 in the list, and then I'll go to this node, I'll find 3, so my list now contains 1 2 1 3. That's it. If I have another node, if I have another tree of the same, then I will have another list called 1 and the elements are 1 2 and 3, so they are equal, then the tree structure of the tree is identical. So there are many corner cases you might have to take care. So I suggest all of you, if you know the logic, then now you know the logic, then try to implement the problem. If not, then I will be here to help you. So here the function is a def is same tree. Yeah, this function is given by leetcode, and you have to fill the fill these all these lines. This only one function is given, this empty function is given, you have to complete the function. So the tree is 1 2 3. What is our first step? Our first step is to traverse through all nodes. Okay, then keep the values of the nodes in a list. So I write a I wrote a function here and name it as visit. So you might thinking what is P and what is Q. P is the root node and Q is the root node of another tree. Okay, I want to traverse this node, I'll call this P. Okay, the root node is passed here as a parameter in the visit function. Then I will do what? then I will check if p is equal to none. Then you might be thinking, what is none and why I am checking this none? Because if it's a leaf node and it's the root node, why it is called a leaf node? Because it has no more children. So 3 also has no more children. So 2 also has no more children. So we can assign that the true children of two are none and none. Here presents none and here presents none. Here also in 3 also we have two children which are none and none. Okay, that's why it is called leaf node. So here we are checking. So if p is equal to none, no, p is or this node is not null or none. Okay, so our program will not enter into this part of the program. So then I will move to this part, a dot append. So what is a? A is our list. Why I make it global? All of you now know it, because if this function is defined outside of this function. Okay, this list is defined. I'm sorry, this list is defined outside of this function. That's why I have make it a and make it global. So that's why I can access this and change the value of a. So now I append the a p dot val. What is p dot val? If suppose I'm this node and called it as p, if I write dot val, so I'll get the value 1. If I write dot left, I'll get the value as 2. I'm at this node and I get left, then I'll get the value of this node, that is 2. If I am at this node and I write dot right, like this, the name of the node is op. If I write p dot right, then I'll get 3. If I write p dot left, then I get 2. So what I did here, I just use recursion here. Using recursion, I just call the same function, that is visit. I just call the same function visit p dot left. Okay, what is p dot left? P is this node. Okay, now p is now this node. What is p dot left? P dot left is this node. Okay, I've called this function again. It is called recursion. And if you don't know recursion, there are tons of videos on YouTube. You can go and check this out. And if you want me to make a video on recursion, just comment below. I'll make videos, 2 videos, that is 3 videos and videos on recursion. So that will help you clear your fundamentals. Visit p dot left. Okay, so p dot left is a 2. So 2 is passed through this. 2 is passed to this visit function. So our cursor will move to this again. Okay, so now p tree node. So now p is a 2. We check if p equal to none. No, it's not none. So the cursor will not move to this part. Then our cursor will move to a dot append dot p dot val. Okay, so a dot append p dot val. What is p dot val? Our node is p is now 2. So what is p dot val? 2. So 2 will append in a list. Now our list contains 1, 2. Okay, now our list contains this 1, 2. Then we will do what? Then then the next line of the code execute. Then visit p dot left. Now our p is 2. So 2 dot left, there is nothing. So we will pass 2 dot left is none. Simply. So 2 dot left is none. So none is passed here. Okay. When none is passed here, is p is equal to none? Yes. So I will append none here. Okay, none is append here, and I will simply return it. So this line of code, so it will not execute. After returning it, this line will be executed, and then here the p value is 2. Here the p will be 2 because p will left executed, then p right will be executed. Okay, so p dot right. What is p now? P now is 2. 2 dot right also null. So this will pass here. So then cursor will again move to this point. Visit visit. Then p, here p is null. Okay, p is equal to none. Okay, then then none is also passed. So p is equal to none. The condition satisfied. Then I will append none here. So now this none is appended here. Okay, now returned. Okay, now when returned, this line when returned, the cursor will move to the fast iteration of the recursion. So that is when p value is 1. Okay, when p value is 1, we recurse our recursion start, and p dot left was 2. So with 2, then for 2 we have recurse 2 times, that is 1 time for its left, 1 time for its right. After finishing all this, our cursor will move to again here we will write p dot right. Okay, p dot right is visit p dot right. p dot right is your 3, so 3 is passed now in this widget function. Now cursor again move to this point, and p is here 3 is equal to none. No, so p dot 3 a dot append p dot val is now 3, so 3 is appended here. Then you might think how this none come from. So p dot left, what is p dot left? P dot left is none. P dot right is also none. So visit p dot left. So here none is passed. Here it comes, then again our cursor comes to this point. Then check p is equal to none. So a dot appended none. Okay, this none is appended. Then this line is executed, and then this line comes. Visit p dot right. Yes, p dot right visit. P dot right is also none. So cursor will move to this point and check if p is equal to none. Yes. So then it will append that non value in this. Okay, so now this part is completed. This is all about recursion. This is very simple. There is nothing to know about it. So okay, this is, but visit p, we have written visit p. Okay, when we write visit p, p is 1, so 1 is passed. Then this line code is when we write, okay, simply tell you my mistake is, so visit p, I blundered some time, so I'm sorry for that. When I write, when cursor comes to this point, visit p is what, 1, so 1 is passed. Okay, and then we come to here, and all the tags I have told you is executed like this. Then I make another list called b, and the value of a is here, the value of a is this, and I have copy the value of a in b, so b is at same as a. Then I will clear the value of a, so I cleared it. Then I again call visit.q. Q is, if in our first example you have seen, the q is at same as this tree, so this so let's assume this is also q. When I write, when the cursor moves to this point, visit q, so q, the root node is passed here. Then I will come to this function, so p.tree root node. Now this tree is also 1, so now again the same things will go on. Okay, and at last, what is your c is equal to a dot copy, and a is the clear first one. First is this, then we will clear it by using this line. Then again a will be the value of a will be here, like from this line of code. Okay, when you pass visit.q, the a value will be appeared as here. Okay, then we make simply c equal to a dot copy, so we copy the value of this and in this. Then we check if b equal to c. Okay, yes, all the elements of b are equal to c. That's why it returned true, else it will return false. It can handle all the corner cases. You might want to try it, and this is for the video. You can copy and paste it. The last time limit for the problem is deadline for the problem is today 12 a.m. So before that you might you have to submit your code. So go and solve the problem in leetcode. I will provide the link for that in description box. Okay, take care, bye bye, thank you.